Okay, now start. Yeah.
Seriously?
Yeah.
What we're going to do here today is we're going to show you how to calibrate the pressure compensation using a new and improved software on the 3010 MA. So what we have is the 3010 MA. First of all, you have to install the new software. You have to make sure you've allowed it to stabilize for preferably at least 3 hours. And then you want to attach a cylinder of 100% oxygen to it using a mass flow controller. Not a flow meter in the valve, but a mass flow controller. We have one down here. We have the control unit down here and the mass flow controller here. This is 0 to 100 SCCM, set to half scale. Okay? And we also have, in this case, we have a vacuum pump. You don't have to have the vacuum pump. We have a pressure regulator, a back pressure regulator, which you really need. So let me disconnect this. We're going to go to atmospheric pressure. And on the analyzer, we're going to go to the different screen, hit system, hit the button over here to get the more, hit enter. From here, we see the raw sensor output, and we see the pressure reading on the A to D converter. We're going to allow this number to become stable. It's getting pretty stable. Right now our flow meter reads about half scale. This one is a 0 to 200 SCCM flow meter, and your flow meter may vary, but that one reads about half scale. That's 100 SCCM. Vented atmospheric pressure. When we change the pressure, that will not read correctly. So from here, we're going to go to the more key again, hit enter, and see we have pressure calibration floating up in the corner, flashing. And again, you see this raw sensor, we see the atmospheric pressure output and the pressure counts. We're waiting for this number to become stable. We're going to hit enter. And here we see high and low pressure calibration numbers. We're going to do the low calibration. We press enter here. And when this number becomes stable, we're going to accept it. Pretty stable, we'll accept that. Okay. We have a reading just happens to be 100% now because it was previously calibrated. Your number, what it says right now, does not matter. Next, we're going to change the pressure. You'll be able to change the pressure by putting a valve on the outlet of the analyzer, or putting a restrictor on the outlet of the analyzer. The important part, if you go back to the screen that shows the count, oops, no, wrong button. Okay. This number right here, we want it to go up by about 10%. It was reading 105 at first. Let's see, we want to go about 111. The exact number really isn't important. Only that it's about 5% above the other number, the atmospheric number. So we're going to wait for this to become stable. And since we're using a mass flow controller, the flow through the analyzer will remain the same. It's controlled by the mass flow controller. If you attempt to do this with a valve, you're probably going to have poor results. It's getting stable. Use the more key again. P-cal is flashing. Hit enter. This time we're going to go and do the the high calibration, because we have a high pressure. Right? Hit enter. It says Cal high. Waiting for this number to stabilize. Kind of stabilize. Exciting. Close. We hit enter to accept that value. We go to analyze. It says something. But what we do at this point is we go and we'll span the analyzer, but we're going to span the analyzer at atmospheric pressure. So we're going to go back to atmospheric pressure. All right. We go back to the information screen. And this is going to return to the original value, which was something around 105 that we had. And again, since we're using a mass flow controller, we do not have to correct the flow of the analyzer. Now this is becoming stable. We have the raw output of the sensor again and the pressure sensor reading. Right? We're just looking at this to see when it's stable. Once it becomes stable, we go back to analyze. We're going to span. In this case, we're doing a manual span. We hit enter. We're spanning at 100% oxygen. Enter again. And we watch our slope, waiting for the slope to become 0. It is 0. So we hit enter. This is our new span point, 99.99% at atmospheric pressure. Now, there's one other thing we have to do. We have to set the pressure compensation factor. To do that, we're going to go back up in pressure. So I'm going to reconnect this. Go back to our information screen again. We're waiting for this number to become stable. And it should go back to the number it had previously approximated. Now what you want to do is you want to go back and look at the oxygen level and see if it's reading 99.99 where we expanded, only to higher pressure. To go back to analysis, close. We can actually try to compensate this. We go to system, more, gets us to the previous screen, more once again. We move over to the P factor screen. We hit enter. This is what our current P factor is. If you turn it down some, then maybe to 0.5 or maybe 99.54, hit enter. Analysis. Let's try it again. This is 100.08. I think if we go down, our number will go down. Enter. Okay, we're going backwards. One screen too many. Come over to the P factor screen. Hit enter. We need this number to go up slightly. 999. Analyze. Wow, 999 is a magic number. We're exactly back to where we were with span. Now in this case, because I have a back pressure regulator over, I can adjust it to a number of other pressures just to verify this. So what we're going to do here, just to demonstrate, of course now it's properly spanned and the pre-pressure factor is already set. I'm going to change the pressure in here to a new one. Now we were about 5% above atmospheric pressure. And now we're something below atmospheric pressure, maybe about 4%, maybe close to 5%. From this screen, you have to hit Analyze to see what the actual reading is. 98.99. That's it. Fully pressure compensated. This will work over a wide range of approximately plus and minus 5% of atmospheric pressure, maybe as much as plus and minus 10% of atmospheric pressure.
All right.
That's it.